Chapter 4, Part 3 of The Origin of Species by Means of Natural Selection by Charles Darwin. Read for LibriVox.org by Michael Armenta. This LibriVox recording is in the public domain. On the degree to which organization tends to advance. Natural selection acts exclusively by the preservation and accumulation of variations which are beneficial under the organic and inorganic conditions to which each creature is exposed at all periods of life. The ultimate result is that each creature tends to become more and more improved in relation to its conditions. This improvement inevitably leads to the gradual advancement of the organization of the greater number of living beings throughout the world. But here we enter on a very intricate subject, for naturalists have not defined to each other's satisfaction what is meant by an advance in organization. Among the vertebrata, the degree of intellect and an approach in structure to man clearly come into play. It might be thought that the amount of change which the various parts and organs pass through in their development from embryo to maturity would suffice as a standard of comparison. But there are cases, as with certain parasitic crustaceans, in which several parts of the structure become less perfect, so that the mature animal cannot be called higher than its larva. Von Baer's standard seems the most widely applicable and the best, namely, the amount of differentiation of the parts of the same organic being in the adult state, as I should be inclined to add, and their specialization for different functions, or, as Milne Edwards would express it, the completeness of the division of physiological labor. But we shall see how obscure this subject is if we look, for instance, to fishes, among which some naturalists rank those as highest, which, like the sharks, approach nearest to amphibians, while other naturalists rank the common bony or teleostine fishes as the highest, insomuch as they are mostly strictly fish-like, and differ most from the other vertebrate classes. We see still more plainly the obscurity of the subject by turning to plants, among which the standard of intellect is of course quite excluded, and here some botanists rank those plants as highest which have every organ, as sepals, petals, stamens, and pistils, fully developed in each flower, whereas other botanists, probably with more truth, look at the plants which have their several organs much modified and reduced in number as the highest. If we take as the standard of high organization the amount of differentiation and specialization of the several organs in each being when adult, and this will include the advancement of the brain for intellectual purposes, natural selection clearly leads toward this standard. For all physiologists admit that the specialization of organs, inasmuch as in this state they perform their functions better, is an advantage to each being, and hence the accumulation of variations tending towards specialization is within the scope of natural selection. On the other hand, we can see, bearing in mind that all organic beings are striving to increase at a high ratio, and to seize on every unoccupied or less well occupied space in the economy of nature, that it is quite possible for natural selection gradually to fit a being to a situation in which several organs would be superfluous or useless. In such cases, there would be retrogression in the scale of organization. Whether organization on the whole has actually advanced from the remotest geological periods to the present day will be more conveniently discussed in our chapter on geological succession. But it may be objected that if all organic beings thus tend to rise in the scale, how is it that throughout the world a multitude of the lowest forms still exist? And how is it that in each great class some forms are far more highly developed than others? Why have not the more highly developed forms everywhere supplanted and exterminated the lower? Lamarck, who believed in an innate and inevitable tendency toward perfection in all organic beings, seems to have felt this difficulty so strongly that he was led to suppose that new and simple forms are continually being produced by spontaneous generation. Science has not as yet proved the truth of this belief, whatever the future may reveal. On our theory, the continued existence of lowly organisms offers no difficulty, for natural selection, or the survival of the fittest, does not necessarily include progressive development. It only takes advantage of such variations as arise and are beneficial to each creature under its complex relations of life. And it may be asked, what advantage, as far as we can see, would it be to an infusorian animalcule, to an intestinal worm, or even to an earthworm, to be highly organized? If it were no advantage, these forms would be left, by natural selection, unimproved, or but little improved, and might remain for indefinite ages in their present lowly condition. And geology tells us that some of the lowest forms, as the infusoria and rhizopods, have remained for an enormous period in nearly their present state. But to suppose that most of the many now existing low forms have not in the least advanced since the first dawn of life would be extremely rash, for every naturalist who has dissected some of the beings now ranked as very low in the scale must have been struck with their really wondrous and beautiful organization. Nearly the same remarks are applicable if we look to the different grades of organization within the same group. For instance, in the vertebrata, to the coexistence of mammals and fish, among Mammalia, to the coexistence of man and the ornithorhynchus, among fishes, to the coexistence of the shark and the lancelet, Amphioxus, which latter fish, in the extreme simplicity of its structure, approaches the invertebrate classes. But mammals and fish hardly come into competition with each other. The advancement of the whole class of mammals, or of certain members in this class, to the highest grade, would not lead to their taking the place of fishes. Physiologists believe that the brain must be bathed by warm blood to be highly active, and this requires aerial respiration, so that warm-blooded mammals, when inhabiting the water, lie under a disadvantage in having to come continually to the surface to breathe. With fishes, members of the shark family, would not tend to supplant the lancelet, for the lancelet, as I hear from Fritz Müller, has as the sole companion and competitor on the barren sandy shore of South Brazil an anomalous annelid. The three lowest orders of mammals, namely marsupials, edentata, and rodents, coexist in South America in the same region with numerous monkeys, and probably interfere little with each other. Although organization on the whole may have advanced, and be still advancing throughout the world, yet the scale will always present many degrees of perfection. For the high advancement of certain whole classes, or of certain members of each class, does not at all necessarily lead to the extinction of those groups with which they do not enter into close competition. In some cases, as we shall hereafter see, lowly organized forms appear to have been preserved to the present day from inhabiting confined or peculiar stations where they have been subjected to less severe competition, and where their scanty numbers have retarded the chance of favorable variations arising. Finally, I believe that many lowly organized forms now exist throughout the world from various causes. In some cases, variations, or individual differences of a favorable nature, may never have arisen for natural selection to act on and accumulate. In no case, probably, has time sufficed for the utmost possible amount of development. In some few cases there has been what we must call retrogression, or organization. But the main cause lies in the fact that under very simple conditions of life, a high organization would be of no service, possibly would be of actual disservice, as being of a more delicate nature, and more liable to be put out of order and injured. Looking to the first dawn of life, when all organic beings, as we may believe, presented the simplest structure, how, it has been asked, could the first step in the advancement or differentiation of parts have arisen? Mr. Herbert Spencer would probably answer that as soon as simple unicellular organisms came by growth or division to be compounded of several cells, or become attached to any supporting surface, his law, quote, that homologous units of any order become differentiated in proportion as their relations to incident forces become different, end quote, would come into action. But as we have no facts to guide us, speculation on the subject is almost useless. It is, however, an error to suppose that there would be no struggle for existence, and consequently no natural selection, until many forms had been produced. Variations in a single species inhabiting an isolated station might be beneficial, and thus the whole mass of individuals might be modified, or two distinct forms might arise. But, as I remarked towards the close of the introduction, no one ought to feel surprise at much remaining as yet unexplained on the origin of species, if we make due allowance for our profound ignorance on the mutual relations of the inhabitants of the world at the present time, and still more so during past ages. Convergence of character. Mr. H.C. Watson thinks that I have overrated the importance of divergence of character, in which, however, he apparently believes, and that convergence, as it may be called, has likewise played a part. If two species belonging to two distinct, though allied genera, had both produced a large number of new and divergent forms, it is conceivable that these might approach each other so closely that they would have all to be classed under the same genus, and thus the descendants of two distinct genera would converge into one. But it would, in most cases, be extremely rash to attribute to convergence a close and general similarity of structure in the modified descendants of widely distinct forms. The shape of a crystal is determined solely by the molecular forces, and it is not surprising that dissimilar substances should sometimes assume the same form. But with organic beings, we should bear in mind that the form of each depends on an infinitude of complex relations, namely on the variations which have arisen, these being due to causes far too intricate to be followed out, on the nature of the variations which have been preserved or selected, and this depends on the surrounding physical conditions, and in a still higher degree on the surrounding organisms with which each being has come into competition, and lastly on inheritance, in itself a fluctuating element, from innumerable progenitors, all of which have had their forms determined through equally complex relations. It is incredible that the descendants of two organisms, which had originally differed in a marked manner, should ever afterwards converge so closely as to lead to a near approach to identity throughout their whole organization. If this had occurred, we should meet with the same form, independently of genetic connection, recurring in widely separated geological formations. The balance of evidence is opposed to any such an admission. Mr. Watson has also objected that the continued action of natural selection, together with divergence of character, would tend to make an indefinite number of specific forms, as far as mere organic conditions are concerned, It seems probable that a sufficient number of species would soon become adapted to all considerable diversities of heat, moisture, etc. But I fully admit that the mutual relations of organic beings are more important, and as the number of species in any country goes on increasing, the organic conditions of life must become more and more complex. Consequently, there seems at first no limit to the amount of profitable diversification of structure, and therefore no limit to the structure of species which might be produced. We do not know that even the most prolific area is fully stocked with specific forms. At the Cape of Good Hope and in Australia, which support such an astonishing number of species, many European plants have become naturalized. But geology shows us that from an early part of the Tertiary period, the number of species of shells, and that from the middle part of this same period, the number of mammals has not greatly or at all increased. What, then, checks an indefinite increase in the number of species? The amount of life, I do not mean the number of specific forms, supported on an area must have a limit, depending so largely as it does on physical conditions. Therefore, if an area be inhabited by very many species, each, or nearly each species, will be represented by few individuals, and such species will be liable to exterminations from accidental fluctuations in the nature of the seasons, or in the number of their enemies. The process of extermination in such cases would be rapid, whereas the production of new species must always be slow. Imagine the extreme case of as many species as individuals in England, and the first severe winter or very dry summer would exterminate thousands on thousands of species. Rare species, and each species, will become rare if the number of species in any country becomes indefinitely increased, will, on the principle often explained, present within a given period few favorable variations. Consequently, the process of giving birth to new specific forms would thus be retarded. When any species becomes very rare, close interbreeding will help to exterminate it. Authors have thought that this comes into play in accounting for the deterioration of the aurochs in Lithuania, of red deer in Scotland, and of bears in Norway, etc. Lastly, and this I am inclined to think is the most important element, a dominant species, which has already beaten many competitors in its own home, will tend to spread and supplant many others. Adolphe de Candolle has shown that those species which spread widely tend generally to spread very widely. Consequently, they will tend to supplant and exterminate several species in several areas, and thus check the inordinate increase of specific forms throughout the world. Dr. Hooker has recently shown that in the southeast corner of Australia, where apparently there are many invaders from different quarters of the globe, the endemic Australian species have been greatly reduced in number. How much weight to attribute to these several considerations I will not pretend to say, but conjointly they must limit, in each country, the tendency to an indefinite augmentation of specific forms. Summary of chapter. If, under changing conditions of life, organic beings present individual differences in almost every part of their structure, and this cannot be disputed, if there be, owing to their geometrical rate of increase, a severe struggle for life at some age, season, or year, and this certainly cannot be disputed, then, considering the infinite complexity of the relations of all organic beings to each other and to their conditions of life, causing an infinite diversity in structure, constitution, and habits, to be advantageous to them, It would be a most extraordinary fact if no variations had ever occurred useful to each being's own welfare, in the same manner as so many variations have occurred useful to man. But if variations useful to any organic being ever do occur, assuredly individuals thus characterized will have the best chance of being preserved in the struggle for life. And from the strong principle of inheritance, these will tend to produce offspring similarly characterized. This principle of preservation, or the survival of the fittest, I have called natural selection. It leads to the improvement of each creature in relation to its organic and inorganic conditions of life, and consequently, in most cases, to what must be regarded as an advance in organization. Nevertheless, low and simple forms will long endure, if well fitted for their simple conditions of life. Natural selection, on the principle of qualities being inherited at corresponding ages, can modify the egg, seed, or young as easily as the adult. Among many animals, sexual selection will have given its aid to ordinary selection by assuring to the most vigorous and best adapted males the greatest number of offspring. Sexual selection will also give characters useful to the males alone in their struggles, or rivalry with other males, and these characters will be transmitted to one sex or to both sexes according to the form of inheritance which prevails. Whether natural selection has really thus acted in adapting the various forms of life to their several conditions and stations must be judged by the general tenor and balance of evidence given in the following chapters. But we have already seen how it entails extinction, and how largely extinction has acted in the world's history geology plainly declares. Natural selection also leads to divergence of character, for the more organic beings diverge in structure, habits, and constitution, by so much the more can a large number be supported on the area, of which we see proof by looking to the inhabitants of any small spot, and to the productions naturalized in foreign lands. Therefore, during the modification of the descendants of any one species, and during the incessant struggle of all species to increase in numbers, the more diversified the descendants become, the better will be their chance of success in the battle for life. Thus, the small differences distinguishing varieties of the same species steadily tend to increase, till they equal the greater differences between species of the same genus, or even of distinct genera. We have seen that it is the common, the widely diffused, and widely ranging species, belonging to the larger genera within each class, which vary most, and these tend to transmit to their modified offspring that superiority which now makes them dominant in their own countries. Natural selection, as has just been remarked, leads to divergence of character, and to much extinction of the less improved and intermediate forms of life. On these principles, the nature of the affinities, and the generally well-defined distinctions between the innumerable organic beings in each class throughout the world, may be explained. It is a truly wonderful fact, the wonder of which we are apt to overlook from familiarity, that all animals and all plants throughout all time and space should be related to each other in groups subordinate to groups, in the manner which we everywhere behold, namely, varieties of the same species most closely related, species of the same genus less closely and unequally related, forming sections and subgenera, species of distinct genera much less closely related, and genera related in different degrees, forming subfamilies, families, orders, subclasses, and classes. The several subordinate groups in any class cannot be ranked in a single file, but seem clustered round points, and these round other points, and so on in almost endless cycles. If species had been independently created, no explanation would have been possible of this kind of classification. But it is explained through inheritance and the complex action of natural selection, entailing extinction and divergence of character, as we have seen illustrated in the diagram. The affinities of all the beings of the same class have sometimes been represented by a great tree. I believe this simile largely speaks the truth. The green and budding twigs may represent existing species, and those produced during former years may represent the long succession of extinct species. At each period of growth, all the growing twigs have tried to branch out on all sides, and to overtop and kill the surrounding twigs and branches in the same manner as species and groups of species have, at all times, overmastered other species in the great battle for life. The limbs divided into great branches, and these into lesser and lesser branches, were themselves once, when the tree was young, budding twigs, and this connection of the former and present buds by ramifying branches may well represent the classification of all extinct and living species in groups subordinate to groups. Of the many twigs which flourished when the tree was a mere bush, only 2 or 3, now grown into great branches, yet survive and bear the other branches. So, with the species which lived during long past geological periods, very few have left living and modified descendants. From the first growth of the tree, many a limb and branch has decayed and dropped off, and these fallen branches of various sizes may represent those whole orders, families, and genera which have now no living representatives, and which are known to us only in a fossil state. As we here and there see a thin, straggling branch springing from a fork low down in a tree, and which by some chance has been favoured and is still alive on its summit, so we occasionally see an animal like the ornithorhynchus or lepidosiren, which in some small degree connects by its affinities 2 large branches of life, and which has apparently been saved from fatal competition by having inhabited a protected station. As buds give rise, by growth, to fresh buds, and these, if vigorous, branch out and overtop on all sides many a feebler branch, so by generation, I believe it has been with the great tree of life, which fills with its dead and broken branches the crust of the earth, and covers the surface with its ever-branching and beautiful ramifications. End of Chapter 4, Part 3. This LibriVox recording is in the public domain.